Okay, part two of Introduction to Trig Functions. We're dealing solely here with sine and cosine. All this is saying up here is that if you know, let's say for example, the measurement of one of the angles, either sine or cosine, let's say 30 degrees, okay? So the sine of 30 degrees is going to be equal to the cosine of, notice what they're saying to do up here. It says we're just going to take whatever the angle was that we had over here for sine and subtract it. So 90 minus 30, because that's what they use for their theta, would say cosine of 60 degrees. So all they're saying is these two things would be the same. So if the ratio of the sine of 30 degrees equals 5/7, then the cosine of 60 degrees would also equal 5/7. So only sine and cosine have this relationship, okay? So notice that the measurements together have to add to 90 degrees. So it's not the sine of 30 is equal to the cosine of 30. It has to be the other measurement that would allow these two measurements to total 90 degrees, okay? So let's prove it in our examples. So I know that may not have clicked for everybody. So let's look at the examples and we'll prove it. So number 3 and 4 go with this same picture, okay? So we're looking at what is the sine of A. Notice in this picture, you don't have a little man standing in a corner, and you don't have theta in any of this triangle. So what you have to do is focus on the angle that they told you to pay attention to. In this example, that would be angle A. So what I'm going to do is I'm going to circle angle A. So that means that we're looking from the perspective of angle A. So if I was to draw my little person in here, this is where we're standing, okay? And they will always tell you which angle you're looking at. They have to, because without that, you don't know how to set up anything. All right, so if I'm looking at A, then I already know this side is my hypotenuse, because that is the side that's across from the right angle. It is the diagonal side. All right, looking at A, this would be the opposite side, because it is the side that is directly across from A. And by default, that makes 16 the adjacent side. So now we have to go back and remember, what was that saying that we learned on how to set up this? SOHCAHTOA. So SOHCAHTOA. And that's going to help me set up this ratio. So we're looking at sine. So I'm going to say the sine of A equals, remember by using this, we know we're looking at opposite over hypotenuse. So what is opposite? The side that's opposite is 30 degrees. I'm sorry, 30, the measurement of 30, that is not an angle, over H, which is hypotenuse. So what is the measurement of the hypotenuse? It is 34. All right, and that is the ratio. That's what we've learned on the above examples. Now we're going to prove that the cosine of C, which is the other acute angle, is also 30 over 34. Okay, so let me clear off my picture here. So now, since this says C, we're looking at it from the perspective of C. So I got to change my little man. Now the little man is standing over here. Okay? So we're looking at it from his perspective over here. Now the hypotenuse always stays the same, so I don't have to worry about that. But the cosine is adjacent over hypotenuse. So we're going to say cosine of C equals the adjacent side. This would be opposite, and 30 would be the adjacent side if we're looking at it from the point of view of angle C. Okay, so that would make this ratio adjacent, which is 30, over hypotenuse, which is 34. And we need to simplify these fractions because they can be simplified. So that would mean 2 goes into 30 15 times, and 2 goes into 34 17 times. So the cosine of C is 15 over 17. And the sine of A is the same thing when we simplify it, 15 over 17. So we've just proven the theory that I showed you in the beginning, okay? They didn't tell us what the measurement of A and C are, but we know that sine and cosine of the two other angles have to give me the same ratio. And they do. Okay? So now let's look at the second example. Alright, so we're looking at the two acute angles. The first one is Z, and the second time we'll be looking at it from the perspective of X. Okay, so we're going to put our little man at Z right now because we're going to do the sine first. Alright, so if I do sine, then I'm doing opposite over hypotenuse. From the little man's perspective, the hypotenuse is always the diagonal side, which is the side across from the right angle. So this is my H. Alright, from his perspective, then opposite would be this side, and this would be adjacent because it is right next to him. Alright, so sine of Z equals opposite 24 over hypotenuse, because sine is opposite over hypotenuse, and the hypotenuse is 26. So we need to simplify this. They're both even numbers. You can divide this in your calculator. 24 divided by 26 gives me 12 over 13. So the sine of Z equals 12 over 13. Alright, now we're going to check the cosine of X and see if it has the same measurement. Okay, so we have cosine of X equals, and we got to redo all of our stuff up here because we're not looking at it from the perspective of Z anymore. The little man is going to be standing at X. Okay, so from his perspective, this would be the opposite side. This is still hypotenuse because hypotenuse is always across from the right angle, and 24 would be the adjacent side. So notice how we have to rename them when we look at it from a different angle's perspective, okay? Alright, so cosine of X, cosine is adjacent over hypotenuse. So which one did we mark as adjacent? 24 over hypotenuse, which is the side we marked with 26. And if we simplify that, we get 12 over 13. So the cosine of X equals 12 over 13. And we have just confirmed this little theorem that they gave me here. Okay? So the cosine of one of your angles is equal to the cosine of the other angle. Alright? Now we're going to take this to the other page and we'll finish up today's lesson. So now it asks me to use the same theory, the sine and cosine, cofunction, to find each one of the answers. So they're saying the sine of 28 degrees is my theta, okay? So what should that be equal to? The cosine, see, we see cosine on this side, and we have to take 90 and subtract it from whatever the angle is that they gave you originally. So if we do 90 minus 28, we get 62 degrees. So the sine of 28 is equal to the cosine of 62. Notice if you add 28 and 62, you get back to 90. Okay? So let's look at 8. Alright, so this one says the cosine of 10 degrees. So we're looking for the sine this time because I gave you cosine. So this one would be the sine of what? 90 minus 10 gives me 80 degrees. So the sine of 80 degrees is equal to the cosine of 10. Notice when you add 10 and 80, you get back to 90 degrees. It cannot be bigger than 90. It can't be smaller than 90 because that's all we have left. Remember, one of the angles is already taken because it's a right angle. Alright, so number 9 asks us to create a triangle. My triangle is ABC. And stay with me, we are almost done, okay? So I have triangle ABC, and they say the measurement of angle B is 90 degrees, and I should have known that I should not have drawn my triangle like this because we've been talking about right triangles the whole time. I was rushing, trying to hurry up and finish. Alright, so we have a right triangle, and we have A, B, and C, where B is the right angle because they said B is 90 degrees. Now they tell me that the cosine of A equals 3 over 5. They're asking me for the sine of C. Now we know that the cosine of one of the angles, the small angles, and the sine of the other angles will be equal. So if the cosine of A is 3 over 5, then what do you know about the sine of C? Correct. It must also be 3 over 5. That's what we just proved on the other side. So if you remember, on the other side of our paper, down here at the bottom, if we do the sine of one of our angles and the cosine of the other angle, look, we got the same thing each time, 12 over 13. So whatever your ratio is, it will be the same. So if they told me the ratio is 3 over 5 here, then the sine of the opposite angle must also be 3 over 5. Okay? So in this example, they're asking us to find the theta. So we're doing what we did in this example. Notice that these two numbers had to add together to give me 90 degrees. So if one of the angles is 15 degrees, what should the other angle be so that they are equal? Remember, when we add these two together, 15 and this angle, we have to get 90. That is what this theorem tells me up here. Remember, we start with 90, we subtract it out. So when I add them, they have to give me 90. So if one of them is 15, we can just subtract. 90 minus 15 gives me 65. So that means theta is 65. So that it looks like this. Sine of 65 equals cosine of 15. If I add 65 and 15, we get back to 90. Okay? Last example. You guys are doing great. Please make sure that you stay focused. If you need to go back and watch this video at any time, please go back and visit my website. Okay? So they say, draw the stick man standing where the angle is. The angle is here, so I'm going to draw my stick man right here. Okay? Mark each of the given sides. When they say this, they mean mark it as hypotenuse, opposite, or adjacent. So if we're looking at it from his perspective, the diagonal side is H. That's hypotenuse because it's across from the right angle. From his perspective, 11 would be opposite. So they want us to tell which one of our trig ratios do we have if we have opposite over hypotenuse. Now I'm just going to write the little mnemonic device that we use to remember this. So, ka, toa. Okay, so if I have opposite over hypotenuse, which one is it? Opposite over hypotenuse. That means I have sine of 61 degrees is 11 over x. And we are not solving for x. That will be in the next lessons to come. So I just wanted you to be able to identify that we had the sine function here because it was opposite over hypotenuse. Okay? So your quiz will entail questions like 7 through 10 and of course 1 through 6. So it would be best for you to go back and watch this video at home the day before the quiz to make sure that you remember all of this stuff and that is fresh on your brain. Alright? Thank you so much. You guys have been great. Please make sure you keep up the good work. I've been getting good reports from Ms. Hall. Please don't forget about the pizza party for the class that has the highest average and is the best behaved. Okay? You have a quiz next class, so don't come in here acting like you didn't know. Alright? Have a good day.